Why is quality factor, Q, important for inductors and capacitors? Imagine tuning a radio or setting up a high-fidelity speaker system. The clarity and sharpness of the sound depend a lot on the quality of the components inside. That's where the concept of the quality factor, or Q, comes into play for inductors and capacitors. It's a measure of how well these components store energy compared to how much energy they lose as heat. Think of it like a scorecard for efficiency. In electrical engineering, the Q factor is a simple ratio that compares the reactive power, which is the energy stored and released each cycle, to the real power, which is the energy lost as heat. For an inductor, the Q is calculated by taking the inductance, which is how much the inductor resists changes in current, and multiplying it by the frequency, then dividing by resistance. For a capacitor, it's the inverse. You take one divided by the product of the capacitance, the frequency, and resistance. When the Q is high, it means the component has low resistance compared to its reactance, so it stores energy more efficiently. Why does this matter? Well, a high Q in inductors and capacitors means less energy is wasted as heat, which makes the whole circuit more efficient. Less heat means less cooling needed and longer-lasting components. It also helps circuits that relying on resonance, like filters and oscillators, perform better. These circuits depend on sharp peaks at specific frequencies, and high Q components make those peaks more defined. This results in better frequency selectivity and more precise tuning. In resonant circuits, a high Q also means the oscillations can last longer, because there's less damping. This leads to cleaner signals and less distortion. Plus, at resonance, the voltage across an inductor or capacitor can be many times higher than the input voltage, thanks to the Q factor. This voltage amplification is useful in radio frequency applications and signal processing. So, in simple terms, the Q factor tells us how good an inductor or capacitor is at storing energy without wasting it. It influences how well circuits work, how efficient they are, and how sharply they can select or amplify signals. When designing or analyzing AC circuits, paying attention to the Q factor helps ensure everything runs smoothly and efficiently.